In this module, we're going to talk about business intelligence. So, broadly defined, business intelligence is a category of applications technologies and processes for gathering, accessing, and analyzing data to help business users make better decisions. It's a category of applications, technologies, and processes for gathering, accessing, and analyzing data to help business users make better decisions. We see a lot of different types of terminology now that fall under the umbrella of business intelligence. Data analytics, big data, business analytics. These are all really catchy, hip terms that really are talking about a lot of the same types of things. Again, if you remember from big data, we have so much data coming in from all these different sources that we are, as I said before, we're drip. Data rich, information poor. We have so much data, and yet from that, we don't actually have a lot of information. Remember, information is data that's been processed into something meaningful. With all of these different data coming in, or all the different data coming in from different sources, business intelligence is all about trying to transform that into useful information to help decision makers or business users make better decisions. Okay, so before we actually jump into understanding this aspect, I suppose we should probably think about what do we mean by decisions? What are decisions? And so Herbert Simon actually proposed three-stage process of decision making. So Simon he proposed three-stage process for decision making. And basically, anytime that we make decisions, we will go through these three stages. Now, so Simon didn't invent this. What he's doing is he's saying he thinks this is how we go about doing the process. And so the first stage is intelligence. Intelligence. This is where we examine the situation, we identify, we define the problem. So we could say problem definition. Intelligence. This is where we define our problem. Second stage, design. Design. And this is where we construct the model that simplifies the problem. So we construct the model. That simplifies the problem. Okay, intelligence, design, and then third one, choice. And this is where a solution is selected. Intelligence, design, and choice. Simon would say that whenever we make decisions, we go through these three-step processes. We understand what's the problem that we're trying to solve. We come up with a model to simplify the problem, and then we choose our solution. When we then think about making better decisions, essentially what we're trying to do is use information systems to actually help the decision makers. And so we may, when we talk about problem definition, right, all of the data coming in from multiple sources, what is it that we're trying to solve? Are we a grocery store that are trying to figure out what product to stock based upon expected demand? We then would define our model. Now, it's an interesting thing because when we talk about models, I suppose we should say, well, what do we mean by a model? What is a model? So a model is a representation of some phenomena in the world. When I was young, I lived in the West Coast, and our class did a field trip down to the San Francisco Bay, where they had a model of the entire bay. And it was a physical model. So in this warehouse was a scaled version of the entire bay of the San Francisco Bay. And so underneath the Golden Gate Bridge, I believe the depth of water there is around 300 feet. So in this model, there was a scale that was the deepest part of the bay. And why did they do that? Well, they constructed that model to be able to simulate what about if a 20-foot wave comes in, if there's an earthquake that brings in a large wave, and that wave comes in, how would that affect the different areas within the bay? And so they could run through these simulations using that model to test what would happen with this wave propagating through the entire bay. Now, again, this was when I was little, and so there weren't really super sophisticated computer simulation models like there are now. So we'd be able to create that type of model now with a computer simulation and do all sorts of what-if scenarios. And the reason we would do that is we would say, okay, what should we do to help reduce the effect, let's say, of a 20 or a 50-foot wave? And then we could run through that model, we could run through that simulation, and we could then choose what we want to do to actually mitigate that possible risk. So that's one example of a model. Another example of a model could be something along the lines of, I've been teaching at this university for, let's say, 10 years. It's been a little longer than 10 years, but 10 is a nice, easy number. And I've taught, on average, 100 students per semester. So that's 200 students a year. For 10 years, that's 2,000 students. So I've had 2,000 students come through my classes. And what if we want to figure out what are those attributes of students that would help us understand grade performance? And so if our outcome, in this case our decision variable, is Scheibe's grade, that's our decision variable. That's the outcome that we would want to understand. Of the 2,000 students that I'm talking about, there's all sorts of input variables, or in statistics we would call these independent variables. And so there's any number of independent variables. They can just go on, ... Things like what, and so the question would be, what influence do these variables have on my decision variable? Meaning, what factors would play a role in a good grade in my class? So you could say, oh, well, hours studied. Right? Hours studied. We think that the more hours you study, there is a direct positive relation or correlation between the hours studied and, whether you get an A, B, C, F. Hours studied. That could be an input or an independent variable. How about your incoming GPA? Do you suppose that your GPA would have an influence on what your outcome in terms of describing what are the attributes of the students, of those 2,000 students? Are there commonalities amongst these input variables? So GPA. Let's say I'm collecting all sorts of data and performance on homework. That could be. What about hair color? I mean, it's a variable, right? What about gender? What about participation? Do you come to class? Do you engage? Do you ask questions? So I could construct maybe 100, 200 different independent variables, and then what I'd want to do is create a model, and if I'm going to take a statistical approach, maybe what I would do here is I would use something like a regression model. I would regress all of these independent variables onto the decision variable to find out what influence each of these would have specifically to that outcome. And so I could use regression to basically describe the influences of these variables on my decision variable. And what you might find is, okay, yes, hours studied, this is a strong positive correlation. GPA, strong positive correlation. Homework performance, strong positive correlation. Hair color, no significance, right? The color of your hair is not significant. Maybe shoe size. How about height? How about gender? How about ethnicity? What about how many courses you're taking that semester? What about, have you had an internship? Are you a non-traditional student? What year are you? Those are all variables, and maybe some of those would have a strong relationship on this. And so essentially what I'd want to do is come up with a model that would describe this phenomena, which then is an interesting part of business intelligence, is that there are different types of analytics. And the first one that I'm mentioning here is something that's called a descriptive analytic. Descriptive analytic. I'm describing, given a set of data points that I have, and in this case 2,000 students, with all of these different independent variables, what I'm trying to do is describe, I'm creating a model that describes how those things, how they relate ultimately on my DV. That's a descriptive analytic, and that's the first one that I've mentioned.